Naval Surface Warfare Center, Dahlgren. He's going to share about some things that he's doing, and I'm not going to try to describe it because I will do a terrible job with it. But with that, Alvin, thanks for coming, and we'll hand it over to you. Thanks.
Okay, good afternoon. Just a little bit of background. I've been working.
Make sure they're recording it down online. They might pause.
Okay, can you verify that we're recording?
We are recording.
Okay, thank you. So again, Dr. Alvin Murphy. I've been working with combat systems for around 33 years now, but basically when basically a combat system, and again, my focus is on surface ships, basically takes the sensors, the command and control, the weapons, and the comms gear, and brings it together as an integrated package that allows a ship, a surface ship, to do warfighting, like to take out threats, if you will. Initially, a lot of that was done manually, where you had people that were sitting in front of radars and people plotting locations of things. But as the pace got faster and faster and changes over time, we needed something that allows us to detect things and order engagements immediately. So that's where kind of the combat systems evolved. This first slide here talks about why are we working on a new system called an integrated combat system. The thought there is today, if you look at what's happening in the Red Sea and other things, the enemy is moving fast. Our peer adversaries are creating new threats constantly, but we need something that allows the Navy to more quickly build solutions and respond to those threats. So that alone is the main driver for what I'm doing, but also having a DevSecOps piece. So if you look at industry like Amazon and places like that, being able to also more rapidly add capability. So this slide kind of shows the changes that we've gone through over time. So on the left side of the chart in the legacy columns, we essentially had multiple directorates, if you will, that were responsible for different combat systems for different ship classes. So at the top, you had IBS 1 that was focusing on destroyers, cruisers, surface combatants, if you will. You had foreign military sales in 4. In 8, basically had frigate, LCS, some of those platforms. And then in 10, you had basically the flat decks being the carriers and the amphibs. So what we've done to move quickly, as I stated, is working towards kind of a common infrastructure in the middle. So acknowledging that on each of the ships, you'll have different suites of weapons, sensors, comms gear, but having a common core that we can rapidly upgrade. So when you upgrade once, you're able to deploy those changes to many, and they're all at the same level. So this is kind of the organization that we stood up to be able to address that need. The majority of these charts are actually available online, but they seem like a good way to present visually some of the concepts that I'm talking about. Had a little bit of trouble getting something released publicly through the Navy, so it made more sense to go back and grab some of these. But I'm under the technical director, so I work directly for the chief engineer. My job is the chief system of system architect for the integrated combat system. So I focus primarily in that area, but I work very closely with the folks that are doing the software development and the DevSecOps types of things. Across the top, we have the major business areas, if you will. So we have the ecosystem, which is basically a facility that's in Maryland, where our software developers meet. But part of that ecosystem is in the cloud. So we have both unclassified IL5, as they call it, impact level 5, as well as classified impact level 6 that provides areas for developers to go build software. And we've got the software teams themselves. They're the ones that are using the ecosystem. The ecosystem also provides various pipelines to go off and evaluate security and those types of things. We've got a team that's working on the infrastructure. So there's a hardware factory that's in King George, Virginia, that actually builds the common hardware to go be deployed on the platforms. And then obviously we have a business operations unit. Down below, you see the major program codes that we had before, but again, they're more of a recipient of the development, and they coordinate getting things to the ships. So last year, Jason Hunter gave the talk. I worked very closely with him, but he talked about a couple of bullets regarding initiatives that we had to put in place in order for people to understand DevSecOps. So at the very top, everybody was really used to it taking a long time to deliver something. So 6 to 8 years you'll hear using waterfall methodology to get things out there. So what we started to do is have conversations with various companies to really understand what they put into place to go faster. So you may have heard of the project Kessel Run. It's an Air Force project for upgrading their air operations centers. Had a lot of visits with those guys, met with Amazon. We went to data centers to understand what those things look like. But really back in 2018 was the starting point. Another thing that we did is we actually brought on some companies through an OTA to allow us to go off and understand and to prototype things in the cloud. Rolling back for a second, the other big thing that we did was going out to USS Monterey and installing some of this modern hardware and demonstrating our ability to send updates over the air, which is awesome. So imagine a ship's about to go into a mission in theater, being able to send stuff digitally over the air directly to them so they can ingest that upgrade. So with the OTAs, there was one that we stood up in 2019. I was actually the technical point of contact for the company. It was Salute, and they taught me a lot. I learned about containers. I learned about a continuous deployment, continuous integration, all the different features of what DevOps really was. I got so excited about it that I actually pursued my PhD with those technologies. So I focused on the suitability of some of those technologies for a hard real-time system, a combat system, but again, it applies to self-driving cars and that sort of thing, but really got to focus on understanding and learning at that point. We had some OTAs for console design, OTAs for the IaaS, so our computing infrastructure, but those are all things that Jason Hunter was really involved in and had me supporting him there. But one of the things that he pointed out, and again, I listened to his talk from last year, were the standardization issues. You talk to one vendor and they would use their terminology for some framework, if you will, that they were offering. You talk to another company and then you realize that some of the things that they're presenting to you are things that may even be open source. So one of the things that he was recommending is the terminology issue. So as you're using DevSecOps terminology, we're on the same page regarding what the pipelines are doing, the types of checks that we would be doing, security checks, that sort of thing. And then he also talked about some of the things that we had in process for the integrated combat system. So moving from a traditional contract, combat system engineering agent, which is a one-stop, buy everything from one place, to where we have more of a system integrator, system engineering, software integration contract, where they're more of a partner with us that helps us bring in other small businesses and other companies, not only for capabilities, but to also increase the competition and the price of different things, and they provide innovation. So that was really good. And then instead of having the software development at the CSEA's facility, we wanted to make sure that the government had ownership. So that's why the Forge was developed. So it's in College Park, Maryland, but that's where a lot of our development happens, as well as up to the cloud. And then also enabled us to open the space for third parties. So again, if you're a prime developer, do you really want to have third parties in your spaces, but it allowed the government to kind of manage that. So that was really good. And then we talked about, again, being able to disperse geographically the folks that are developing the software, and the cloud is a real enabler for that. So for IL5, we're using Black Pearl. So that's the Navy's initiative. So that provides the I'll call it the gold standard, if you will, but the containers that we're using, they do all the accrediting of that stuff. But we also have pipelines on top that run the various tests to go look for vulnerabilities and that sort of thing. And then for IL6, we're using Microsoft Azure, but over time we'll converge to a common solution. Go ahead.
Quick
Mhm.
summary of what IL5 versus 6 means and what you can do on those.
Okay, so IL5 is GovCloud. So that's unclassified GovCloud, but you can handle CUI and other levels there. IL6 is when you move up to secret, and then you've got levels above that. So just talking about some of the pipelines, this is kind of a graphic that we pulled together to show some of the changes that we had to make. Big ones, we're looking at changes in the infrastructure that we have. So that's for the forge as well as the computing stacks that we go out into the ships. Looking at how we would modernize things over time, because it can't be a big bang for us, right? How do we develop in stride? We've already begun integrating software to ships that have we'll call it heritage code, but having sandboxes that communicate with that heritage code to allow us to deliver some capabilities. And then obviously the culture, right? Changing the culture so we can go fast, which is not where we were. And then again, the comparison between the waterfall and then where we are with agile, continuous loop, continuous feedback, if you will. And then the quote on the right side of the chart talking about the 3 ways, but talking about the 3 ways for moving faster. So trying to put all that in place as well. So another big thing that's been going on is establishment of governance. There's actually a book called Wiring the Winning Organization. It's another book by Gene Kim, who's one of the DevOps masters, if you will. But it talks about layering your organization so that you have the decision-making authority at the right level. So as a system architect, I'm the enterprise architect that you see across the SAFE roles. Then we have solution architects. So our customers will define different solutions. It may be things like track management. It may be things like track association. But at that solution level, they'll communicate with expertise, domain experts that may be track management experts, maybe sensor experts, but they will make decisions about that design, that being the requirements in the architecture. And then at the lowest level, you've got the system architects, but we use the term product architects. So those are the ones that are making decisions about the structure of the software they're building. So understanding that governance process, and then again at the enterprise level, I'm more so focused on patterns and approving patterns that they'll use at the lower levels. But understanding those terms, I think, is something else that we would look at standardizing. So if you do want to follow things like SAFE, you have the governance process. And we've also been discussing various reviews that we would hold along the way. So we've got a thing called a solution work package. And what that does is it drives the objectives. What are the goals of what we're doing? How did they flow down from the top level within our organization down to the goals that we have for particular solutions? Talks about funding constraints, talks about when the ships need it. So again, as you're making decisions about the design, you have those roadblocks, if you will, to be able to, or guardrails, I should say, to be able to help make decisions about what makes the most sense at the time. And then the lower level below that, you would have traditional things like your system requirements. So at the ICS level, the combat system level, it would be unallocated requirements, but the things that the system needs to do as a combat system. And then those are allocated down to subsystems, being the core itself, the infrastructure, and then what the weapons and sensors and comms need to do. In companion with that is the design document. So the system subsystem design descriptions. So those would be at the ICS level, as well as defining the software components, if you will, and the structure of those, the functionality that's allocated, the inputs and outputs, the interfaces, if you will, and then pushing that down to the software requirement specifications that are down for the product developers to manage. Okay, so this is pretty much the last slide, but this is where I'm wanted to provide some ideas where we could go contribute to the DevSecOps standardization process. One of the things that we created early on was a reference model. So the reference model essentially was divided into domains of the combat management system. So that's the piece in the middle that interfaces the weapon sensors and comms, and broke that down into things like track management, engagements, sensor types of things, training, right? But inside of that, we had major boxes of functionality. So for example, on the weapon side, we have a weapon coordinator product, and then we have a weapon controller product, with the thought that that product would be common, but it would have variability mechanisms to allow it to interface with different weapon types. Similar construct on the sensor side, where we have a sensor coordinator that coordinates not only local sensors, but the sensors on the other ships in the group, with a common controller concept that allows us to adapt rapidly to a new sensor. Within that architecture is an adaptation layer. And again, the thought being, where today we have a different component for every sensor type that we have, you would have a common data model internal that would allow you to just mediate the unique information from a sensor over weapon and use the existing common ontology, so you can use that weapon or sensor and get 80 to 90% of its capability before making any changes, just by having that adaptation layer. So over time, as you want to take advantage of other features that that weapon or sensor can provide beyond what you currently have, you can evolve that over time. So there may be different modes that a sensor has or a weapon has, that sort of thing. So the reference model, I think, is key. That allows us to really work with different vendors and catalog what sort of capabilities they're able to bring, what sort of products for AI, ML, those types of things, and catalog where they fit into our architecture. And then the common data model and ontology, we've been trying to get at that for years, but there's a number of standards out there. There's a joint command and control information data model, JC3IADM, if anybody's heard of that, but that's probably the closest, that's probably the closest to something that we have that's published that defines terms. But again, we want to be able, across the combat system world, all be on the same page regarding the various functions that you would have of the system. There's also a joint standard, joint common system function list that we use as well, that J6, the joint community, manages. But again, that has like over 2,000 different functions. We did a study a number of years ago, back in 2012, and pared it down to more like 253, because there's a lot of overlap. But again, that's been instrumental to us because we map it to the requirements and allows us to see across our programs what functions each of them are doing. I think we talked earlier in Matt's talk about some of the common DevSecOps terminology. I'm not sure if you guys have seen the CNCF.io reference model. It is a hodgepodge of products across the board that they're monitoring, right? But in that model, they have different groups of types of things. So things that like build software, things that scan software, right? But that may be a good start for how you would bin certain things in terms of the types of tools that you have. There's also a document that I'm going to provide to Matt that when we started on our journey, we had a gentleman, Nicholas Chilean, that was working for us. He was working for the Air Force. There was a document that he signed that had a lot of different terms, and I remember having constant discussions with different communities about what those terms should be. So that may be another good starting point. And then the last big one I want to point to is the metrics. So we've got pipelines that are auto-generating things. So ideally, every time you commit your software to our repository, those metrics are being generated and they're being cataloged somewhere, so you can go back and look at how you're doing. But again, coming up with what are the metrics that we're doing that are related to the software design itself, how rapidly, how many commits we're making, but be able to go have those things as a common set of things that people would use. So we can look at across organizations and see how everyone is doing. I believe that's my last slide. I included some references. So the top references where I borrowed a number of these slides from our deputy program manager. The governance piece is the bullet in the middle. And then again, with my dissertation, I did a lot of looks into DevOps and how some of those tools work. So you're open to look at that as well. And that's it for me.
So there was a system and they were working on it back in the 80s. It was supposed to do this. You remember I can't remember the name of it. But it was going to coordinate the sensors on the ship and then the sensors with the weapons, and then realized they could do it across ship, and they realized they could do it.
Yeah. So the question was, yeah, that's the system in the 80s that used to do some of this coordination. Yeah. So there was CEC, it's the cooperative engagement capability. That's primarily focused on sensor coordination. But I'll even go back further to 1955 when the Naval Tactical Distribution System was introduced, NTDS. If you go read the history of that, it's a lot of was what they were going after, but it just couldn't materialize to their budgets and that sort of thing. So, okay.
Questions for Alvin, which will be our Navy customer here at the moment.
Yeah, and I'll say that I'm very excited about what you guys are trying to do with the standard. And there's a number of people working with me that I'll definitely want to reach back to and see if they can help, primarily developers and some of the small businesses that are helping us coordinate this stuff as well. So, but thank you.